next one, page 91, because it's a graph question, they give you the formula as well, which is really nice. They say the formula for voltage is voltage at the beginning, E minus T over R multiplied C. So what they want you to do is to work out, what type of graph is this? What's the name of the shape? What type of graph does this make? Is it a straight line graph? No, it's called exponential. So what they want you to do in the first part is to change this into a linear. So in other words, how can we cancel the E? Log, yeah. So what we do now is we have log V equals log V0 E minus T over RC. So we have log B equals log V0 plus log E minus T over RC. Now what happens with log and E? They cancel. So you get log V equals log V0 minus 1 over RC T. So you get log V equals minus 1 over RC T plus log V0. So what we can do is we can say put log V on the y-axis. So that means that y equals log V. Put time t on the x-axis. That means that the x is equal to t. So we now get y equals minus 1 over RC t, t, which is x, plus log V0. So I hope you can see that the slope m equals minus 1 over RC, and the intercept c, small, now this, please, this c is different to this c, it says small c, c equals log V0. That was kind of a lot of work for only 2 marks. It's only 2 marks. But it's really like a maths question from maths class. So maybe this is good for you. Can I go to the next part? Yeah. So in the next part, can you see the diagram they have? I'll draw it here again for you. What they have is this. They have a cell, 12 volts. A capacitor, a switch, a resistor, 5 microfarads, 12 volts. So what happens here is, in the circuit, switches A and B are closed. The 5 microfarad capacitor is charged to 12 volts, and the current flows through R1 only, since R2 is short-circuited. When A is then opened, the capacitor begins to discharge through R1, and the values are shown. And this is done over, after a time 30 seconds, switch B is open, so the capacitor then discharges to R1 and R2. So what they're saying here is, at the beginning, this is closed, and there's a switch here, and this switch is also closed. And basically the capacitor charges up, etc. So the capacitor charges up. Then what they do, went a bit far. Then what they do is they open this and then they close this. So in this situation, because this is open, the battery is now removed. Can you see that? If this is open, the battery is removed because the current can't complete a loop. So when this is open, it's no longer charging. So if it's not charging, what's it doing? It's discharging. So what you get now is a current from the capacitor starts to discharge. But this switch is closed, and the reason they say it's closed is because this is broken. So the current avoids the resistor. So it only goes through the one resistor here like this. So basically the problem at the beginning is a simple problem of a capacitor is discharging into a resistor of R1, and the capacitor is 5 microfarads. So at the beginning it's like this. Then what happens? 30 seconds later this is opened. So then when it's opened, then the current passes through it. So it's like it gets 2 resistors. So are we clear what's happening? For the first 30 seconds, how many resistors are being discharged through? 1. And then 30 seconds later, it's like the R2 is connected, and there's now continues to discharge but through 2 resistors. Anyway, the first part of the question isn't even about that yet. It's about the table. Okay, so do you see the table there? We have time and log voltage. Oh, and voltage. So what's missing from the table? The log voltage. Do you know what the voltage is? Yeah. So for example, at the beginning, what's the voltage? 12. And then next, 10 seconds later, 9.82, and so on. So what we need to do first on our calculators is to complete the table by typing in log 12, log 9.82, log 8.04. Yeah, so let's do that first. So that's 3 marks. Marks for free. No need to think. So here we have time. Oops. I'll remake the table. Time in seconds. Potential difference in volts, and then log volts in log volts units. So the time goes 0, 10, 20, 30, 40, 50, 60, 70. The voltage goes 12, 9.82, 8.04, 6.59, 6.33, 6.08, 5.85, 5.62. So now log voltage. So what's log of 12? Ln 12, please. 2.4849. Yeah, good. So like this. Yeah. Okay, yeah, I should do it like how you have in the exam, huh? So we should, I think I would do 3. Now, here's the beautiful part. What do they ask me to do next? Draw the graph for how many marks? 8 marks. Yeah, I know, I'm shocked too. It's great, isn't it? So, I don't need this one anymore, so I'm going to delete this, okay? Oops. Yes, for 8 marks, they would expect you to use the ruler. Okay. Right. So in the exam, yes, use a ruler, and the graph should look like this. So I'll do insert chart. Okay. So scatter like this. Now, what's the title? Well, this is 2006 B6 A2. What's on the x-axis? What do I put on the x-axis? Time. And the unit? Seconds. And on the y-axis? They see it's log V, yeah. Log V, and the unit is log volts. Yeah. So this is a little too big for you to see, so let me shrink it down a bit. Okay. I mean, yours will look much nicer because it'll be on a bigger page. Okay? But you get the idea. You should have something nice on graph paper. Now, so that's 8 marks. I know I did my 8 marks very quickly. Next part, find the values of the slope of the 2 straight lines. So why are there 2 straight lines? Oh, I know what I'll do. I'll put this in paint. Why do they say 2 straight lines? Any ideas? No?
Just when odd two.
Yeah. What's happening here, don't forget that there's like 2 parts to the story. The first part is with 1 resistor, and then the second part is with the 2 resistors. Whoops. I wanted to copy it into paint. Copy. Copy. Paste. Hold on. Copy. Alright, I'll have to show you on the board with my finger, so here, look. What they mean by 2 straight lines is, here's the first straight line for this part, from 0 to 30. And then the second straight line is from here, 30 to 70. Okay? So let's get the slope for the first part. So, how do you calculate the slope? It's the height over the base. So, what's the height of this triangle? If I draw a triangle here, what's the height, do you think? Yeah, well, what are the 2 numbers? Here's 2.5, and then down below? 1.886. Yeah, okay. Well, let's pretend we're reading from the graph, so maybe we get like 1.9. Alright. Now, what's the base? How big is the base? 30. So can you write this down? The first slope is minus 1 over 50. You got that? First slope is minus 1 over 50. Okay. Now let's get the second slope. This will be more difficult. What's the height here? 1.8 to 1.4?
It's still 1.7.
Okay. Yeah, and then, how big is the base? 30 to 70, how big is that? Isn't it 70?
40.
40. So the slope for this one here is going to be a tiny minus 1 over 400. 1 over 400.
What's minus?
Because it's gone down. Can I close this here? Yeah, okay. Right. So in blue, in the first story, we got the slope is equal to minus 1 over 50, wasn't it?
Yes.
But don't forget, here, from the first part of the question, the slope equals minus 1 over RC, remember that? So then here, I can say, minus 1 over RC equals minus 1 over 50. So, you get that the or C equals 50. So then the or equals 50 over C. And what's the C? 5 micro. Is it 50 or 5? Yeah. 50 over 5 times 10 to the power of minus 6. Wow, this is pretty big. 10 to the 7. So 10 mega ohms. Now in the second half of the story, there are 2 resistors. So now we get the slope equals minus 1 over 400. So then I have minus 1 over RC equals minus 1 over 400. So RC equals 400. So R equals 400 over C. And in this case the C is still 5 micro.
It's
80. Now we're not finished. 80 mega ohms, because that 80 is for for the total. So we can now say R1 equals 10 mega ohms and R2 must be 70 mega ohms. Oh yeah, I just did the next part too. Find R1 and R2. So there's one good piece of news for you in the physics exam. They always have a graph question in one of the questions. So remember, I think yesterday, which question had the graph in it for us? In which questions we have to make a graph? I think we did this yesterday, didn't we? Did we have to do it in the mechanics question yesterday? The time velocity graph?
We know about it.
Okay, we didn't do that one yet. Well, anyways, my point is, there's always one graph question. So if it's in mechanics, it will be velocity time. If it's in electricity, it could be this, but there are other graphs. And if it is in waves, there is a graph which is on your worksheet, which we didn't do. But don't worry, the graphs, as you can see, the graphs are easy to do because notice how, see here how they give you the table? Yeah? So look, even if you didn't understand physics, they give you the table. How do we get the missing row? That's log V. So even if you didn't do physics, you know how to do log V. And then we take the 2 and we put it on a graph. And then when we draw a straight line, we measure the slope. Is any of that to do with physics? Not really. It's more to do with math, isn't it? Mm-hmm. But the good news is, it's like, the graph question is like 10%, you know? It's more than 10% because it's 844, so that's 12%. No, 16%. 16%, wow. 16% is a lot for a graph. So I think My advice to students every year is always do the question with the graph in it. You should always do that. It'll help your mark.